Namaste.
We are privileged to present ourselves at 39th National Convention on Quality Concepts 2025, focusing on theme
क्वालिटी कॉन्सेप्ट्स for आत्मनिर्भर विकसित भारत.
with the team Synergy Squad presenting Bhubaneswar manufacturing plant of SMS Group. SMS Group,
Leading partner in the world of metals.
we celebrate
150 years of shaping the future.
our global presence is in.
More than 100 locations.
We have 4 manufacturing hubs.
2 in Germany,
One in China,
one in India.
In Odisha, we have 2 manufacturing facilities.
One in Khurda and one in Manchester.
Our facilities are equipped for
Heavy fabrication,
critical machining,
Complex assembly. Both the facilities are certified with integrated management system and they are
quality management system,
environmental management system,
occupational health and safety management system.
and energy management system.
Our capacity has grown from 350,000 hours in 2014 to 865,000 hours in 2025. A 127% increase and a 26% higher than 2023. It positions us well to reach our 2030 goal of 1 million hours.
This is a product portfolio. We mainly deal with metallurgical products like
ladder,
police stat,
Transfer car and plasma gas.
some of our customers are
sale,
ABS India,
Oil, Tata Steel.
our theme.
optimization of engineering hours.
Let me introduce our team. I am Sruti Bajaj, team member. Our team leader,
Rajat Kumar Samantray,
our facilitator,
Amit Ranjan Joshi,
team member,
Prabhu Prasad Patel.
team member.
Darshita Sharma.
Our team was formed.
1st May 2025.
We used to meet.
Every Monday for 1 hour.
This is our attendance. Our average attendance is 95%. We show our dedication towards the quality service. This is our presentation content which we will discuss in coming slides. We started our work keeping these prime objectives in our mind. The objectives are
Employee environment,
Self-development,
Team collaboration.
adopt best practices,
efficient time management,
improve work environment,
we are from engineering department, so our stakeholders are
order handling,
purchase
Fabrication. Machine shop.
quality assurance.
and logistics.
So we followed PDCA method as our guiding philosophy. PDCA.
Plan,
Do,
Check.
act.
PDCA helps us for continuous improvement during problem solving. Every project starts with a proper plan for better success. So accordingly, this is our milestone. Our team Synergy Squad followed a scientific approach that is 12 steps for problem solving, starting from
identification of the problem,
to
regular implementation and monitoring.
Now we are at step 1, identification of the problem. Our team followed round-robin technique and listed 51 problems for improvement, considering
quality,
Cost,
delivery,
safety and moral.
these are the 51 listed problems which we are facing in our day-to-day activities. And here the step 1 is completed. Now we are at step 2, selection of the problem. To select the problem, we divided 51 problems into 4 categories. The categories are A, B, C and AK.
A.
problems which can be solved within our department.
Total 9 problems come under category A.
B.
Problems which require the help of other department.
Total 22 problems are coming under category B.
C.
Problems which require the management involvement.
Total of 12 problem falls under category C.
AK.
Problems which can be changed from A to Kaizen.
Total 8 problem comes under category AK. To solve the problem within our department, we selected A category problems. Our team members rated the problems on a scale of 1 to 10 and the highest rated problem is selected for improvement. So the selected problem is extended engineering process impacting timeline. And here the step 2 is completed.
Now we are at step 3, definition of the problem. This is the milestone after week 3. This is engineering workflow starting from input from the order handling. When the scope is clear, we start preparation of drawings and bill of materials and release them to the workshop within the timeline. Also, when we do not have the scope, we return back to the order handling for the clarification. Also, during the execution, we face some unplanned activity which also affect our engineering timeline. And some of them are factory support,
Purchase support,
Supplier deviation,
logistic support,
And vendor support.
engineering plays a vital role in the whole process.
when any delay occurs, it creates pressure on all the downstream activities affecting timely delivery and execution. Consequences of extended engineering hours are
delayed in BOM and document release, KPI is affected,
PYDDC increases.
On-time delivery decreases.
tight schedule for production.
but we cannot change the delivery schedule. So manufacturing schedule is compressed and it may affect our quality.
Ultimately, it affects the organization's ability to achieve its goal.
From the last discussion, we have completed the definition of the problem.
So to define the problem,
Engineering delays affecting project timeline.
Pursue the objective.
Minimize the rework and streamline the query tracking.
What will be our goal?
Our smart goal is to cut overrun by 60%. This is step 4 analysis of the problem. We use 80-20 pattern principle to identify the vital few activities and their manufacturing query and project engineering. We have total 80 engineering hours as we have 10 members in our department. We analyze January to May data to get the issue. We got that due to insufficient input issue, we are delayed by 29 days, and with complete information, we are able to complete the project in 9 days. We use 4W1S method: what, who, when, where, and how much.
What is the problem?
Extended engineering hour.
Who is creating the problem?
Engineering and stakeholders.
When is the problem arising?
During execution and manufacturing.
There is the problem.
Within engineering department.
How much is the delay?
29 days due to input related issues and 9 days for engineering execution. And here the step 4 is completed.
We are now step 5 activity-based causes. So from the data, the reasons for the problems are classified into process category and system category. 3 causes under process category are considered as a major contributing factor for improvement. 3 causes under process category are further classified into controllable and uncontrollable. 2 causes under controllable are only considered for improvement. We have further identified 50 points for the 2 controllable reasons, and these are classified into 4 broad categories with the help of the fishbone diagram. And these categories are
Design and technical challenges.
workflow issues.
Communication gaps.
And resource constraints.
So category B, workflow issue, is the major contributing factor considered for improvement. We have identified 26 causes against the category B, which is workflow issue, and these are rated by Fusity on a scale of 1 to 10, and we have identified the highest points. So those highest points are further classified with the help of a child fishbone diagram using 4M methodology, and they are
And
Method.
Machine.
And material. And here the step 5 is completed.
Now we are at step 6 and in the root cause. We analyze all the causes under 2 categories, method and main. And each was related to debugs and we select 2 external causes under main category for corrective action. Cause 1, delay in project work initiation. Cause 2, frequent work interruption due to queries.
To find the root cause, we performed why analysis for the 2 selected causes. Cause 1, delay in project work initiation.
But
Engineering prerequisites are not fully ready.
why?
Input was not reviewed before planning.
why?
No formal checkpoint exists for input validation.
So for cause 1, the root cause is input validation is not embedded in a workflow.
Cause 2, frequent work interruption due to queries.
what?
Duplicate and repetitive queries are received from stakeholders.
Why?
No formal checkpoint for segregation of duplicate and repetitive queries.
Why?
Documentation and tracking process are not well defined.
So for cause 2, the root cause is there is no digitalized and structured query flow. And here the step 6 is completed.
Now we are at step 7, data analysis. For cause 1, we select previously executed 25 projects and out of those 17 projects were delayed due to insufficient data as a major factor, which is considered 68% delay. And for cause 2, we take last 5 months query and out of those 46% queries are either repeated or duplicate in nature, which you can see we have marked in similar color code. Now with this, step 7 is completed.
We are now developing solution. We have identified 2 root causes and proposed 2 solutions for each root cause, and 1 solution for each root cause got approved for implementation. Our problem 1 is delay in project work initiation. So to resolve this issue, we have proposed an input checklist. So it covers all the required inputs necessary for initiating engineering activities. There are some mandatory particular checkpoints in this checklist like technical document clarity, whether drawings are available in the ERP system or not, job card availability, procurement details, transportation details, whether revision can be expected in the near future or not. So
This checklist to be provided by the project manager to the engineering with the field data. So the engineering will add this project to the engineering schedule.
our problem 2 is frequent work interruption due to queries. So to resolve this issue, we have proposed an engineering query tracking system to log, track and categorize the queries. Our various stakeholders can raise issues and queries by simply scanning the QR code, and all the queries will be recorded in a single interface displaying the query priority, query raising department, details of the query, and also the reference document against which the query is raised. So
If In future, any repeated query will arise. This can be tracked and traced with the system of query tracking system. And here, the step 8 is completed.
We are now in step 9, posting resistance. A clear approval structure is established involving SCM head, production head, engineering head, automation head, and our QC members. This ensures a smooth decision flow. With this, our step 9 is completed.
Now we are at step 10, trial implementation and performance check. This is the trial implementation of engineering work initiation checklist. You can see this was implemented in the month of August for a USA based order. Project manager feeds the data and given to the engineering. So engineering can add these to engineering schedule. This is another query tracking system of the query tracking system. You can see the stakeholders is log their issues in the query tracking system, which can be tracked and traced in the future. This is the data collected from the query tracking system in the month of August. Our stakeholder can simply scan a QR code and digitalize with the query tracking and in the query tracking system with the issue. And this is the data where you can see that 80% of the projects are on time. And here the step 10 is completed.
We are now in step 11, regular implementation. Since the performance of our proposed solution is good, it is planned to implement on all the projects to be executed in our program and Manchester workshop. With this, the step 11 is completed.
So now we are at step 12, that is follow up and review. This is the final step of the 12 step of problem solving method. This step ensures that the improvements which we implemented in our system are now sustained and sustainable. This is achieved through
Understand of the work instructions,
Effective documentation,
Training for all the teams.
And a sustainable plan with clear responsibilities.
we use quality tools and methods like 4W1S method,
YY method,
data analysis.
Exposure analysis. Step final step of problem solving is completed.
This is the plan versus actual milestone chart and the chart is regularized. Before quality survey, we used to take 9 days on an average to complete a project, and after implementing our solution, we are taking 6 days for the same. So the engineering days are reduced by 33%. These are the projects in which our solution is implemented in the month of September and October. These are the difference before quality circle and after quality circle. On the left, you can see the challenges before quality circle, that is
limited problem solving structure,
low employee involvement,
Limited knowledge sharing.
Informal practices.
and after quality circle we achieve major benefits like
employee engagement,
continuous improvement,
Skill development.
Reduced errors.
and a strong culture of quality.
so quality circle transforms a restrictive work environment into a collaborative, empowered